Alright, so if you've ever wondered what that DEG and RAD modes are in your calculators when you hit the mode button at the very top, it's degrees and radians. So angles can be measured in either degrees or in radians. They're usually measured in degrees. So radians are based on pi. So pi is, or it uses pi a lot. I don't want to say necessarily it's based on pi. When you're saying I have pi as an angle, what you're saying is I have 3.4115 blah, 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 blah radians. Okay, so you're often going to use pi when you're discussing radians. So to change from radian measure to degrees, or from degrees to radian measures, you've got to remember that 180 degrees equals pi radians. So there's only 3.141529, so on and so forth, radians in 180 degrees. This is why it was so important to make sure you were in the correct mode whenever you were doing the calculations using trig. Because if you were in radians, you would get a very different number than when you were using degrees. So when you're using radians as your unit of measure, there's no need to write a unit at all. Like degrees, you would use that little tiny bubble up there, but with radians, it's just radians. So 180 degrees equals pi. That's enough. That's all you need. So to convert from one to the other, you create a proportion and cross multiply. So for example, if I want to convert 270 degrees into radians, I'm going to put my degrees over pi, so degrees over radians, so 180 degrees equals pi, so this just equals 1. And I'm going to set that equal to 270 degrees over x number of radians. So I put my degrees on top and my radians on bottom. It's just fine to put your radians on top and your degrees on bottom. It doesn't matter. So I cross multiply, and I get 180 times x, and that's 180x. And then I get 270 times pi. Well, I'm trying to get x by itself, so I divide it by 180. So when I divide by 180, I get 270 pi over 180. And if you put that in your calculator, x equals 3 pi over 2. So 270 degrees are equal to 3 pi over 2 radians. Alright, so why in the world would we need to know this? Well, let's convert a few more times, and then we'll get into why. So a couple more examples. What if we want to go from radians to degrees? So if I want to convert pi over 4 to degrees, again, degrees over radians, degrees over radians. And it's okay that you have a fraction over here underneath the bottom. Your calculator can handle all of that. So what I'm going to do is cross multiply. So I get pi over 4 times 180 equals pi times x. Divide both sides by pi to get it by itself. So 1/4 times 180, excuse me, is 45 pi, because that pi is right there. So, or you can just plug this into your calculator and you'd get 45 pi. When you divide both sides by pi, the pi's cancel out. 45 degrees equals x. So let's just simply set it up, cross multiply, set it up, cross multiply. Alright, so why? Well, this can make arc length extremely simple. I put really simple. I mean extremely simple. So the formula when you're using radians is just the arc length equals your angle in radians times the radius of the circle. That's it. So if you can take the time to convert whatever angle they give you into radians, all you have to do is multiply that times your radius and you're done. So to show you how quick and easy it is, so we find the arc measure of the following. So I wanted to write arc length. So find the arc, not measure, the arc measure is 60. Arc length of the following. So I'm wanting to find the arc length from A to B right here. Okay, I want to find that measure, that length, not that measure. The measure is 60 degrees. So instead of setting up a proportion, I'm just going to convert 60 degrees to radians. So 180 over pi equals 60 over x, cross multiply and divide, and I get x equals pi over 3. So now I'm going to plug this into my formula. So arc length equals angle measure in radians. Now if you're doing this in your calculator at this point, you need to make sure you're using the radians function times r. So your arc length equals pi over 3 times 7. So that's just 7 pi over 3. That's it. You're done. Alright, so again, convert, or you want to find the arc length of AB. Alright, so I'm going to change my radians to degrees using the 180 over pi, cross multiply, divide, and I get 5 pi over 6. Okay, 5 pi over 6 Then I'm going to plug that back in, and 5 pi over 6 times my radius length, which was 10. 5 pi over 6 times 10 is 50 pi over 6. Done. That's all there is to it.